Okay, I want to go over the problems. Start at 217, 218. It says, this is a graph of this P divided by this Q. And it says, what do we notice about this? Well, what do we notice right away from the graph? And so things that we should notice is that there's a vertical asymptote at -2, which means x plus 2 has to be in the denominator. There's a vertical asymptote at -1, which means x minus 1 has to be in the denominator. Looks like there's a vertical asymptote at about 1. Looks like it's just before 1. So I'm not sure what that is, but x, let's see, at -2, so it's plus 2, at -1, it's plus 1, and at x minus maybe 0.9 or something like that. And looks like there's one close to 4. I'm just going to call this 1 and x minus 4. Now let's look at the denominator. The last number is 8. 1 minus 4 times 1 minus 1 times 1 times 2 is 8. So I think those are right. I think these dots are a little bit off. And then I'm going to look at the x-intercepts, and there looks like there's 1 at 0, so that means x. And it's real hard to tell in here if there's any x-intercepts. So got interrupted there, but anyway, can't tell what's going on between 1 and 4 in this picture, but I would love to factor this and find out. So let's just take the x out of this, and that would leave x to the third minus 8x squared plus 21x minus 18. And to get 18, there's probably combinations of 2 and 3. And I'm going to make a rough guess that it goes through plus 2, so x minus 2, and through x minus 3. Just since this book has been doing nice whole factors all the way up to here, that's why I kind of didn't go with the 0.9 that it looks like here. But this would only give me -2 times -3 would be +6, and it's 18, so I'm going to guess that it's x minus 3 again. This would give me -3 times -3 times -2 minus 18. So I'm guessing that's what this does, just by understanding the degree, factoring out the x, and looking at what I have left. Let's see if we can actually factor that. So in here I can see that there's an x squared in the first two, so I'll take an x squared out of these two, and I'll have x minus 8. And if I take on, let's see, not a nice number that comes out of these, that would be 3, that would be, nope, that's not going to factor that way. I was trying to do another possible factoring way. The easiest way to factor it, of course, has been what we've been doing in class, and that is to type in that equation. So Okay, so I'm going to go back up here and type in x to the fourth minus 8x to the third plus 21x squared minus 18x. And if I graph that on Zoom 6, it's what I anticipated. It goes through 0, so 0 is one of the, x is one of the factors. It goes through plus 2, so x minus 2 is a factor, and it bounces at positive 3, so x minus 3 is a factor twice. That's using the calculator. And if I type this one in, I should get this as the factors, going through minus 2, minus 1, plus 1, and plus 4. So, just looking at this graph, I can read that much, and I know that this horizontal asymptote has to be at y equal 1 because the ratio, they're the same degree, so it's the ratio of the leading coefficients 1 to 1, y equals 1. I also know that since each of these factors only happened once, and it can only be these, none of them can be double because it's only x to the fourth for the denominator, that it has to go in opposite directions at this asymptote. It has to go opposite directions at this one, and it has to go at opposite directions at this one, and opposite directions at this one. What I do notice is I don't see anything between minus 2 and minus 1. And if it goes opposite directions, if it's going up on this side of minus 1, it must be coming from below on this side. And if it's going up on this side of this one, it must be coming up from below. So there must be something down here, further down than is showing on the graph, below minus 20. So there's some missing part in here. And because of the scaling on here, I can't see that this comes down. I'm going to exaggerate it. It comes down at 2, must come back up and bounce at 3 and go down. But they squeezed it so I don't see that. And this also must come down and then work its way back up towards 1. So if 1 was up here, it comes down below it and works its way up towards 1 because that's the horizontal asymptote. So, consider the interval from minus 2 to minus 1 on the graph. What do you notice about this particular interval? No curve. You can't see it. For any x in this interval, what is the sign of p of x? So we just look at that, put in a number, and it'll turn out to be positive or negative, and put something like negative 1.5 into q of x. And when we divide them, one of these turns out to be positive, and one turns out to be negative, and so we know that this has to be negative. The function f of x is negative for the entire interval. Yes, we figure out that's negative because we found out one of these is negative, one is positive, so this is negative. And what does that tell you about the behavior of the function between the two asymptotes? Well, we already know it does this. Considering this, does the function have a turning point? Well, yeah, it has a maximum there. He calls them turning point. It's a maximum. And it must be a maximum. So, next part. Set your window so you can see the maximum there. And graphing calculator or Zoom app interval, what do you notice in between 4 and 6? We have to look more closely at that so we can see how this works. And so we can find the minimum and a maximum there. And let's just find those now. So on, let's see, we've got the numerator. So I'm going to go to here, and I'm going to put parentheses around this, and around the end of it, and then I'm going to divide it by, and then I'm going to type in the denominator, which is parenthesis x to the fourth minus 2x to the third minus 9x squared plus 2x plus 8. Now if I graph this, I should see what's in the book, and you can see that it looks pretty much like this, but I think there's stuff down here below this. Right now it's at minus 10, so I'm going to look lower. I'm going to go to my window and tell it to look, and we know it's below 20 from this, so I'm going to go to minus 40 for my low. So there's it going up, there's that, and there it is. So I have a maximum somewhere between minus 2 and minus 1. Let's find it. Second, calculate the maximum between negative 2 and negative 1, and I'm going to look at negative 1.5. I'm going to make my guess for that, and it says it's at negative 1.39, and that maximum, that local maximum, is negative 29.26. So down at the bottom here, negative 29.626. Okay, now we come over here, and it says what's going on in this part. So to see that, I want to widen this out. Since I can't just touch it on my screen on this calculator, I'm going to go to the window, and I want to look at from, I can keep it from minus 10 to 10, but I'm really interested to spread out so that it maybe go from minus 1 for the y up to a possible max of maybe 2. So I'm really focusing on the y. So now I'm going to push graph. And I really need to see more in there. So this is only minus 1 and this is 2, and I need to see more detail there. Let's just go zoom number 2 in on, and I'm going to move over to that place and zoom in on that area. And there it goes down at 2, touches at 3, and bounces. Just like we predicted from the factors, it bounces at 3. So we have a maximum of 0 at 3. So we have a maximum of 0. And we have a minimum inside there between 2 and 3. Second, calculate the minimum between 2 and 3. And I'm going to guess at 2.5. And it says it's at 2.3, and it's the minimum is negative 0.01079, whatever. Okay? That's what I wanted you to get out of this one. Now they do the same one here, and they ask you to look for turning points. That's kind of like max and minimums. And they talk about the ones you were supposed to find. Now, on this part, this is a new one where this is the numerator and this is the denominator. So if I could factor this numerator, it'd be nice. The denominator is a triple asymptote. So if it's on the bottom and it's x to the third, The first time they go opposite, but then it squared would try to make them go the same, and then the third one tries to makes them go opposite. So that's kind of why this thing starts to go up, because it's trying to go the same, but then it says go opposite. It's trying to go opposite, but then it tries to go the same, but then it tries to go opposite. So it gets this side really confused. That's kind of what's happening here. But let's figure out this. Well, it looks like it crosses at, let's see, if that's 2, that would be 1. It looks like it crosses at 1.5. And it looks like it crosses at 3, so the numerator must have a factor of x minus 3, and maybe x minus 1/2, or 2x minus 1. That would be the same, give it the same there. And it looks like there's 1 at negative 1/2. But it doesn't have 4 here, so it looks like it crosses at x plus 1/2. But let's check and find out what it is exactly. So I'm going to go to my y equals and just type in the first part here, x to the third minus 4x squared plus 2x plus 3. Let's make it zoom 6. And so it goes through those places that we notice. What are those 2 places? Well, one is plus 3. So I'm going to determine these more accurately by doing synthetic division. That's 1x to the third minus 4x squared plus 2x and a plus 3, and I'm going to divide out the minus 3, so the root would be 3 plus 3. So 1, 3 times 1 is 3. That would be minus 1. When I add, multiply, I get minus 3. Add, I get minus 1. That becomes minus 3, 0. And what I get is x squared minus x minus 1. So that doesn't factor to nice things. So what I need to do is go back up here and use the quadratic formula on this. So that would be plus 1 plus or minus the square root of minus 1 squared is 1 minus 4 times 1 times, that's minus, plus 4 over 2 times 1. So I've got 1 plus or minus the square root of 5 over 2. So the 2 factors are x, let's see, plus 1/2, so minus 1/2 plus the square root of 5 over 2, and x minus 1/2 minus the square root of 5 over 2. So that's why they don't come out to look like very nice numbers there on here. Okay? All right. So we have to determine the roots of f of x, which we now know are the 2 from the quadratic formula and 3. And the denominator is x cubed, and we get, when we graph this, let's see, the degrees of numerator and denominator are the same, so there's a horizontal asymptote of 1 over 1, which is 1. And there's a vertical asymptote at 0. And identify all the max and min. So there's a max here, and there's a min here, and we can find those by plugging those into the calculator and find the max and min. And they probably do that for you later. And then they give us this one. Determine the roots. Well, this one's pretty easy, I think. x squared factor, see that factors to x, and plus 3 and minus 2 I think will give us the plus x. And the denominator will be cause asymptotes, so let's look here. Let's see, that looks like it's x plus 2 is a factor of this. Looks like there's 1 at 1, so I'm going to guess x minus 1 is a factor. And it looks like there's another one at about 5, so I'm going to guess x minus 5. And just do a little check here. I get x cubed. That matches. And 2 times minus 1 times minus 5 is 10. That matches. So I'm going to guess that's pretty much what it factors to. So then, we've identified the roots. The degrees, let's see, the degree of the denominator is greater than the numerator. When that happens, the denominator grows faster than the numerator, and so the horizontal asymptote is 0. We have a vertical asymptote at minus 2, at 1, and at 5. They all happen once, because there's degree 3, and they got all 3, so there can't be any more. So they go in opposite directions here, and opposite directions here. There'll be a max here. There's a x-intercept there. No max or min there. No max or min there. But this side looks like it crosses at minus 3. So if it crosses there, it goes down below. It must, and if it goes to a horizontal asymptote of 0, there must be a minimum in here. So that's what the tricky one that they want us to find. Everything else should be straightforward. So there's, let's see, do I have that in here? Nope, that's, okay, so I'm going to go, let's see if I can do this. Alpha, no. Okay, didn't work. Okay, clear, so we're going to go alpha, that, make it a fraction. In the numerator, I'm going to put x squared plus x minus 6. In the denominator, x to the third minus 4x squared minus 7x plus 10. And so there we have it. And zoom 6, we have the graph. And that looks like what it was, but that doesn't help us see this part. So I want to look in, I'm going to go, I'll just move over there and zoom in on this area where I think there's a minimum. Zoom to enter. There it's going down, and now it's coming back up. So there's somewhere in here between minus, let's see, what's the farthest over here? Minus 7 and minus 2. Somewhere between minus 7 and minus 2 is a min. Second, calculate a minimum that's between negative 7 and negative 2. And I'll just say, check at negative, oop, didn't do something right here. Second, calculate the minimum between negative 7, negative 2, check at negative, what am I typing wrong? Second, calculate the minimum left bound. Oh, I might be going too far over. Negative 6. Okay, that might not be far enough. Okay. Negative 2 might not be on the screen. Let's see, my window goes from negative 7 to negative 2. It's negative 2 is not on there. That's what's happening. Second, quit. Second, calculate the minimum between negative 7, that's right on the edge, and negative 3. What did I do? Oh, I hit the wrong negative. Negative 3. So -7 to -3, I'm going to guess -5. And it says it's -5.4, and the minimum value is -0.078. That's kind of what they wanted to see on that one. And similar stuff on this one. And then they give you 5 to practice looking for these maximum and minimums. And I will do a separate video of that.